Okay, it's time to do the LED lighting source. I have some super bright LEDs, individual ones, but I also have some LED clusters that I bought a long time ago, and these look pretty good to use right here. I think I'm going to make some sort of a holder to put a cluster into that will then eventually go onto the bracket back here and illuminate down here. Okay, with this here LED cluster here, I'm going to try to do some sort of machining here, a bracket to hold this into. More or less, it's going to fit inside a flashlight type cone, and then I will also design it so that it can tilt and be locked in any position on a tilt. Again, it would look like an instrument because it would have like some sort of a tilting mechanism, a locking mechanism to make it be able to do that. And here's what I'm thinking. I'm thinking that it could look something like, maybe something like this. That I would have the cone, let's say that we would do it this way here. And this would be the LED module. And it would be in a cone shape like that. And then I could have some sort of a bracket situation going on here that could allow this to rotate up and down to direct the light in any direction I needed to. And that will be a bracket that would rotate onto another bracket that will be able to be screwed into the actual project itself. There will be a bracket holding a rotation device that would hold the LED in a cone for locking in a position after rotating it. So let's see what we can come up with here. Okay, I cleaned the drawing a little better now to give myself a better understanding of how it's going to work. It'll be the reflector. This is the reflector right here, the LED module inside here. Then I would have on the back side here, I would have a bracket coming out and coming up, and there would be a screw tightening right here so that this can be adjusted up and down and then tightened with a bolt right here, a small screw tightened. And then this bracket here would be fitted to another bracket that would eventually get screwed in to the saddle, ball of the saddle. That's that angle part later on. But right now the first thing I want to do is just make the cone and get that reflecting cone built first so that the module fits inside, that I can bring the wires out and have enough on the back side to do machining to put a bracket and a hole through there to make a locking mechanism. Let's do that part first. Okay, now for the actual dimensions I will use, I'll make the cone, the reflecting cone. It'll be 1.5 inches in diameter. It will go back. It will go back 3/4 inch, and then it will have a tab on the back side, another 3/4 inch. So it'll be a total of 1.5 inches by 1.5 inches stock, round stock. And then I will machine that to the cone so that it ends up being around 3/4 inch on the back side here, 3/4 inch in. And so I'll have to get that angle and then set my compound to that to get the cone feature with this here back tab here. Okay, there's the dimensions I'm looking for. Okay, here's what I got drawn up so far here. This is going to be, this inner circle represents the LED, which is 3/4. That's the module. Then I'm going to use about 1/8 of an inch for starters of a rim. And here's a side view of it. Now I need to solve for this angle right here, angle A. Now we know that in trigonometry that we have the arctangent, the opposite divided by the adjacent, so we know that the angle A right here, the opposite side to that angle would be this here large A right here, which is this distance from here to here. And we know that the adjacent side to this is this line B right here from here to here. So we know that the arctangent of this angle would be the opposite divided by adjacent, which is A divided by B. Okay. But now comes the part of solving for these lengths. Okay, I know I have 3/4 inch for the module. This is the center line right here, so if I take half of that 3/4, that gives me 3/8 from here to here. According to this here, this is 1.5 inches total diameter. I have 1/8 of an inch rim, so now I have from here to here is 3/4 of an inch from center line to the top is 3/4 of an inch. That's 6/8 minus the 1/8 for the rim. That gives me 5/8. So from the center line to this point right here now is 5/8 of an inch. Now to get to this point right here, we have half of this 3/4, which is 3/8. So we now have the 5/8 minus the 3/8 gives us our 2/8 or 1/4. So we have for A, we have 0.250 inches. For B now, we have 1 inch for total length. 1/2 inch is the module, and then that line goes from the module out to the total length here, so it's 1 inch minus the 1/2 inch, or 1/2 inch for B. So 0.500, and we'll now take 1/4 inch divided by 1/2 inch. We take the arctangent of that, and that should give us the angle A, using this as 0 degrees here, the incline here, and this 0 degrees represents the bedways on my lathe. Okay, let me get this here arctangent figured out here now on the calculator. Okay, that comes out to 26.5 degrees. So then I'll be adjusting my compound slide to 26.5 degrees in that range there to get me pretty close to this kind of a angle of a bore. I'll be boring at that angle, and I will also do the outside angle also on this very same setting at 26.5 degrees. And I will leave a nub back here that I can use to assemble that to a bracket. So I need to think about how I'm going to work the workpiece now in order to do this machine. I have to think through the machining steps now to get maximum efficiency of not wasting a lot of material. And that's what I'm going to show next here. Okay, it looks like the best way to machine this piece would be to keep the whole long bar, and then instead of cutting a small piece off, just keep the whole long bar, which I have right here. And then on the tailstock end, I would work in, and I would machine on the tailstock end this nub all the way up to this point right here. And then once that's accomplished, then I would set my compound slide, and I would machine this outside taper from the nub all the way out. And then once that is done, then I would cut it off to the exact length it needs to be. And then I would turn it around and put the nub to the chuck jaws. And then I would do the internal boring to get the module to fit in here. And then I would do the internal taper boring for this part here. Okay folks, I have a 7x10 lathe. My workpiece is around 9.5 inches. Now of course, using the 3-jaw chuck, you can see there's no way it's going to fit. So of course, I think we all know by now that the 7x10 means that the 10 inches is always in between centers. However, my center is the live center here with ball bearings, which again takes up a lot of real estate right there too. So I would need to have a smaller, a dead center in there, which would be smaller and go in farther. And of course, I'd have to have my plate on there so I can turn between centers. So anyway, because I don't have a dead center for here, but this is all I have for the live center, that's it, I do have some plates made up that I can take this chuck off and turn between centers. But I don't think I'm going to be turning between centers because of I don't have enough room. I may have to come up with something different. I may have to make a small center, I'm not sure yet. But I'll come up with something, or else I'll just cut this block a little bit shorter to fit in between centers. Because I can't cut it too short to fit this, or else I'll be really wasting material. And the reason why I'll be wasting material is because I'd have to have enough to be able to machine the outside taper. This outside taper ends up on the neck here of this nub. And that's the reason why I have to do it this way. If it was just an outside taper, like a regular taper ending up to at 0 here, then it would work okay. I can just cut the piece and just do the taper. But because the nub is here and then the taper comes out, I can't taper in. I don't think. I'm going to see if I can taper in. I might be able to taper in. I'm going to look at this more clearly, more closely. Alright, I decided that's what I'm going to do. I'm going to cut the workpiece to a rough size, saving the material as much as possible, and do the tapering in. I'm going to taper bore or taper the outside diameter, doing that taper cutting from long, wide to short, and then up at the nub. Usually I always taper from short to long. That's the easiest way. Bring the cut this way here out, with the short being toward the tailstock. But this time the long is going to be towards the tailstock, and the short is going to be in the chuck jaws, and I'm going to be tapering into the chuck jaws. And I'm going to see if I can do that. That will work for me. Okay, the first thing I had to do is I had to change the chuck jaws to be able to grip outside diameters larger than 1 inch. This is 1.5 inches, so I have this here, other jaws in here now. But what I'm going to do is, because these here ends are cut very kind of crooked. One was done with a hand hacksaw and the other was done with a bandsaw, and they're not perfectly straight. I'm not going to put the workpiece all the way tight to the back of the jaws, but instead I put the workpiece in just enough that I can have some movement. And what I'm going to do is I'm going to put my dial indicator on there, and I'm going to clock that in as best I can. But by giving myself a little bit of room behind here, I can move this back and forth, and then once I get it clocked in, I'll tighten it up nice and tight, and then I can start doing the facing. And once I get one side faced really good, then I can put that tight against the back jaw and then face the other side, make it parallel. Okay, so it's right back here that I want to do all the facing on. I have the dial indicator as close to the edge here as possible on the back side here, and I'm now watching for the, there's the lowest. And there's where it's the most highest. So I'm going to go ahead and tap this way a little bit. And I'm going to keep on tapping that until I get where I want it. Close enough here. The dial is no longer. I'm going to start tightening up a little bit here now. Okay, now that I have it pretty much where I want it at, I'm close enough. I'm only within about maybe 1 or 2 thousandths. And again, this here is not machined on the side here. This is also rough also. So that gets me close enough. I can now tighten the chuck jaws all the way on all the chuck jaws. And a nice good grip here. Again, shut the dial. Okay, I'm satisfied with that. That's enough to get me in within range that I can actually now face this off and be pretty close to being concentric with the diameter. Okay, now I should be able to put it right tight to the jaws now and be pretty close to being parallel. I don't think I have to clock it in because I just take a look at it and see how it is. Yeah, I think it's real good. Okay, this goes down about an inch. It doesn't have to be perfectly an inch, but just within that range, an inch. That's for the nub. That's going to be gripped in the jaw. Okay, good. Time to change out the chuck jaws and go back to smaller ones now, since I have a good nub that I can grip onto now. Okay. Okay, I think what I'm going to do is I'm going to do the outside taper first, down to that nub, and then I'm going to do the inside bore taper, and then do the boring to fit this inside, and then do a small hole out the back to pull the wires through. Okay, my compound will be set to 26.5 degrees. And we turn in this direction here in this time instead of out. Alright, there's 30. Okay, I have that there nub machined out to here, and then I have a high point here where my chuck jaws are right here on this point right here. So all I'm going to do is I'm going to be machining from the outside edge back to the inside edge. I'll be machining this taper from the front edge here to the back edge. When I come out the back edge there, I know that I have the taper to the length it needs. It looks like the plan of attack is this. I'm going to be tapering a little bit this direction here like this, pull back, bring my cross slide in further, come in, pull back, and just keep on going until I reach the front edge here. When I reach the front edge, then I have the exact amount I need of taper. I just realized a mistake right here. This outside angle has to be less than the inside because of the fact that this inside is coming right down to the 3/4 where that fits into. This outside has to leave some meat on here. So I'm going to change this outside angle to make it lower so that it leaves more than it doesn't meet right into the 3/4. It meets above it about 1/8 of an inch. So I'm going to change this outside angle. That means I'm going to change it on the compound here too, or else I'll be taking too much into there from the outside. Okay, here we go. This here outside here is 1.5 inches. This inside here where this taper is going to come down to is at 900 thousandths of an inch. this distance from here to here of the taper is roughly 750. It's about 7, I'm going to call it, let's see here, 770. I'm going to go with 770 just like it shows here. So I have the distance in 770. Now here's the height from here to here that I need to get. And that height is going to determine the angle. The height is around 290. So to get this tapered angle this way, that taper angle would be the 290 divided by the 770. The arctangent of that would give me the angle. Okay, that comes out to 20.6 degrees, so I can set my compound to 20.6 degrees to do my taper in. That would take me from the front edge here and end up on top of here, which is above the 3/4, so that my 3/4 will fit inside there and not touch the module. But the inside taper will touch the module on the inside. Okay, let's get this at 20.6 degrees. 20, 22, about half of that is 20.5, 21, about a little past the 20 should do it. That's about 20.6, 20.5 degrees. That should do it there. Now I'll put this on and I'll double check this. Okay, now just for the check, by me having my bit to the edge of this here, touching this here at the edge, touching on the back edge, I should be able to pull this back now on this taper angle, and I should have the same amount on the front edge coming into the bit, which is about 5/16, around 5/16 or so distance from the front edge to the tip of the bit. I should have close that same distance here coming in this way here. So I'll just take it from the top here and look at it. And very, very close to 5/16. So that verifies that since this distance from here to here is pretty close to the distance from here to inside here, that's pretty close to the degrees that we need here. Okay, we'll give it a try here. I got my carriage locked. I'll advance my cross slide, come in. One thing, I got to keep my bit straight in. That's just a little bit too much taper there on the bit itself. I got to put a different bit in there. Okay, I got my 60-degree threading tool in there, and I got it squared up. And that's all that matters. As long as it's squared up, then it should work properly. Okay, here we go. able to see that. Looking pretty close. Very close it's going to be that angle. I'm almost on the top of the front here. And they are rough measurements too. They want it perfectly exact measurements. They're close in the ballpark. I'm very close here on the paper too. I'm going to pull on it. I'm going to come out on it now by touching the inside a little bit more. One little cleanup pass now. That's good. So one more yet. Nice cleanup pass. Okay, that's it. There's the taper. Comes right down on there, pretty nice. Front of it comes right down onto our nub here. Alright, next is the inside bore, which I gotta adjust the compound to 26.5 degrees to do the inside. But first of all, I'm going to do the 3/4 bore in here first, so far down to put the module in, and then we'll do the taper boring later on. The next thing is to bore the front now to 3/4 inch, that the module will fit in like this. Yeah, or that module is going to fit right into that area right here, that raised area right here. It's going to fit back to there like that. It'll fit back into there like that and stop. and then this will get bored down to that 3/4 hole. So there's where the module is going to be sitting at, the LED module. Okay, I can go to a depth of 1 inch off the face of this here, and that would allow my module to fit in here, back to this back side here comfortably. I have a dial gauge set up here on my tailstock here for drilling, and what I'll do is I'll use this dial gauge against this, and that will tell me. But what I'm going to do is I'm going to stop this at about 900 thousandths, possibly. But I do have the tip here. I'm going to have to take some measurements here and decide where I want to stop this at using the dial gauge. What I'm doing is I'm going to run my drill bit in until the face of it here touches the face of that. That way I know the point, the length of the point, and I'll use my gauge here to tell me when that happens, and then I will know exactly how many thousandths that point is on there. I'm at 50 thousandths right now. $70. 100 thousandths. 125. Right there, I would say about 150. 150. Okay, there's the hole drilled with a 1/2 inch drill bit, and it goes back close to about 1 inch. The next thing to do now will be my boring bar. Now I'll bore that to 3/4 or close to what's necessary for that module to fit in. This module right here again is shown. I want to get that to fit in. So we got to bore that to this diameter here now in this. 635. I need to go to at least 750. Okay, that takes it to 715. This is at 700 and about 10 to 15. So I need to go a little bit at a time now. Go 10, I'll go 20 now this time, 20,000 more. Okay, that's right in there, like, just like it is now, but it's a little bit tight. Or not tight, but it's touching in all directions. But since this is electrical, you run off a battery, the ground, the cathode is the actual ones on the outside is the cathodes here. If that's touching this here, this would just be the negative wire. Go to this here, but I want to get a little bit of room so I can put a little bit of hot glue in there and keep this isolated from the metal. So I'll go to 750 thousandths. I'm at 730 right now, 730 thousandths. 20 more to go. That should give me enough room to get inside there with some glue. Some hot melt glue should take care of that. Alright. Next will be the taper bore. Will be the next part. I need to get the measurements now for that, how far back that goes, and we'll take it from there. Okay, according to my calculations here that I drew up here originally, when I have an 1/8 inch rim, I should be back where I need to be in the taper bore, the distance I need to be when I go with the 26.5 degree taper angle on my compound slide. So I'm looking for an 1/8 of an inch rim. So that's what I'll be doing here. When I get that 1/8 of an inch rim on here, I know I'll have that back to where it needs to be. So first of all, I need to change the compound now to 26.5 degrees. Taper bore coming up. Let me lock my carriage. Put a stop here. Alright, here we go. Making a picture tube, TV picture tube. 200 thou. Let's get right on the edge here. Right on the edge. It's 200 thou. Right on the edge. I can't go in too. If I keep on going in deeper, it's going to keep on widening. So I have to get it right on the very edge here to get the actual measurement. So I'm at 200 thousandths. 75 to go. Now. 155, 45, 35, 25. That's about 135. Now I may take it more down, less than 1/8 of an inch, because I think I might want to even get down to a 1/16 of an inch. We'll see how it works out. I'll just take a little more at a time here now. I'm going to take 1 3 and I'll pass now to the side here. About 2 thousandths. So nice and slow right there. My compound, there's a lot of backlash to it. I think I'm going to clean that up just a little bit more yet. Clean that up just a little bit more yet. My compound is not very smooth compared to my cross slide. If I take my time, I might be able to get a nice smooth, more corrosively. A little bit of time here. It's a little more smoother now. That'll take time. Alright. Let's get the module. Put the module inside. Alright, that's about where I want it too. Where the tops of the LEDs are pretty close to the last, where the bore ends up at, and that's pretty darn close. So I'd say that would work out nice. A little spotlight. That would work really good. Next I have to do is drill now through there for the wires, and that would be it. Okay, there it is so far. Okay, the last operation on the lathe here would be to drill the hole to put the wires through. I'm using a 3/32 inch bit, or I'm sorry, 7/64 to drill this hole through. That hose is a little bit small, so I'm going with a 9/64 bit instead to enlarge the hole. That's at the both sides there. Alright, okay, that looks like that's about all that needs to be done in the lathe. Here's the back side of it, front side of it. Yeah, the better size hole for it. There it is. Just like we drew up this evening. There's the front view of it, and here's my side view. Yep, that looks good. I like that. Alright. Next thing will be to put the modules in. Put the module in there, put some, probably some hot milk glue. Run the wires through, of course. Run the wires through. Hot milk glue it. But before I do that, of course, I got to make the stand for it. I have to make a bracket for it now for it to swing up and down. And that will go on the back side here of the press. It would go back here somehow like this. Make some sort of a bracket that will allow it to swing this way or that way, whatever it needs to swing. Okay, that might be all for tonight. I may just put it on the bar back here, make a bracket to put on the bar, on this bar back here, and let it be stable, and I can actually adjust it one way or another, but have it attached to the bar. Yeah, I think that's what I'm going to do. I think I'm going to do it with the bar instead of put it on here. On the bar here, be like a spotlight for it, if it can, and I can maybe adjust it this way here. That way it won't be moving up and down, it'll just stay in one spot. Alright, that'll work.